Test for chapter 11. First, you were supposed to define the terms. I'm going to go through this quickly because we have so much to do today. An indicator was something that makes an observable change when the conditions in the solution change. Okay? Acid is a proton donator or an H plus donator. A base is a proton acceptor or an H plus acceptor. Amphoteric means that it can act as an acid or a base. Polyprotic, it's giving away two or more protons. Number 2, it says it's sour, so it's an acid. Number 3, it turns red litmus paper blue, so it's a base. Is the following list composed of acids or bases? And it's all cleaning products, so those are bases. Number 5, identify the base and the acid and the base. PO4 3 minus is the base and water is the acid. In number 6, the answer which of the terms in number 1 applies to HPO4, it is amphoteric. Yep. Did anybody put anything else there? We good? All right, number 7, the balanced chemical equations for these. The first one is H2SO4 plus 2NH3, which is ammonia, yields 2 ammonium ions. Oops. And a sulfate ion.
Does it matter which one we put first? I put salt.
Nope, it does not matter. No, sir. Commutative property applies. Number 8, HF plus potassium hydroxide yields water, which you could have written water either way, plus potassium fluoride. Okay, and then the last one, 3H2SO4 plus 2 aluminum hydroxides yields 6 waters, and you could have written water either way, I don't care, plus aluminum sulfate. Okay, here we go. Number 10, which of the following pH values is most likely orange juice? It would be 4.0. Number 11, the answer would be 9.0. If you have a question on any of these, please stop me. Yes, sir?
11, I put 9.0-13.8. It's either or. So I thought it was either or.
Just leave it at 9.0.
Okay.
Because at 13.8, you're actually out of the zone again. Okay, pretty sure. Given the information above, okay, so the next one, number 12. What is the initial color in the flask, which should be pink, and what indicates the end point is purple? Is that what you guys got? Anthocyanins are pink in the absence of acid. I'm up on number 11. Anthocyanins are pink in the presence of acid, purple when neutral, or blue in a weak base solution, and greenish yellow in a strong base. That's why it was 9. So actually, you probably should get half for that one. And then the first one, it says if it's blue, and so the answer would be 9.0 because it said if the base is, if it's a weak base, then it'll be blue. And then on the next one, it says that number 12, it says you start with an acid, which means you go to the one above it, and it says that it would be pink if it's acid. And when it gets neutral, it tells us purple is neutral, so it will go to purple. That's where your answers came from. Okay? Number 13, you have 45.6 mils of 10.1 molar hydrobromic. You need to use magnesium hydroxide to neutralize it. How many grams of magnesium hydroxide are necessary? So we are going to make the reaction first. Our acid plus our ionic base, because magnesium is a metal, group 2 metal. And so we know that is going to make salt and water. So we're going to make 2 waters. So I'm going to come over here and make 2 waters. And then it's going to leave magnesium and bromide, which is a -1. So we're going to flip-flop. This gets the 2. Magnesium gets the 1. check it. There's one of these, there's two of these, there's two of these, and two of these. Okay, so we're good there. Now, we're going to go ahead and put in the given. We have 45.6 mils of this. I'm going to go ahead and make that into liters. And so I'm going to move my decimal place back 3, 0.0456 liters. And then I have 10.1 molar of that to start with. How much magnesium hydroxide do I need to neutralize it? Okay, in grams, that's what it asks for. So I'm going to have to get this to moles so I can go from moles to moles, and then I can go to grams. So my moles are hidden in the molarity. So I'm going to take that and multiply that by the liters so that I can get rid of the liters and just get to moles. That way that'll cancel. And so that's going to leave me in 3 significant figures, 0.461 moles of HBr. Now I'm going to go across the mole tunnel. So I'm going to go like this. Moles of HBr, moles of magnesium hydroxide. There's 1 mole of that to every 2 moles of that. So 3 significant figures, that's going to give me 0.231 moles of magnesium hydroxide. Now I want to go to grams, so I'm going to put the moles of magnesium hydroxide on the bottom so it'll cancel, and the grams of the magnesium hydroxide on the top, 1 mole of that. And let's see, the magnesium hydroxide, the gram molecular weight is 58.33. But our answer has to be in 3 significant figures because we have 3 there. So it's going to be 13.5 grams, that cancels, of magnesium hydroxide. So that's your answer. And if you put the wrong number of significant figures, you're going to have to take off a point. 14. You have 125 mils of a solution of phosphoric acid, but you don't know its concentration. If you titrate the solution with 4.56 molar solution of sodium hydroxide and reach the end point when 134.1 mils of base are added, what is the concentration of the acid? They're doing a titration. And so we're going to start with the phosphoric acid. And we're adding that to sodium hydroxide. We know that this is an ionic base because that's a metal, so we're going to make salt and water. We have 3 hydrogens to go with these, so we're going to need 3 of those hydroxides. So we've got 3 waters. And then we're going to have sodium left. And we have the phosphate ion left, which is a -3. So this is going to flip-flop. This gets the 3. This gets the 1. Check your balancing. We have 3 waters, 3, 3. We have 3 sodiums, 3. And we have 1 phosphate, 1 phosphate. All right, so we're balanced, which is important for our stoichiometry. Then we're told that we have 125 mils of this solution, the phosphoric acid solution, and I'm going to go ahead and move my decimal place back 3 and make that liters. So that's readily accessible for what I need it for. If you titrate this solution with a 4.56 molar solution of sodium hydroxide and you reach the end point, and I'm going to move my mils to liters. I'm going to put 0.1341, and that would be liters. It's no longer mils of the base. What is the concentration? We're looking for the concentration of the acid. So there is my given and my get to, and I've got to go through moles to get from here to here. So I'm going to start by finding the moles of this. Remember, the moles are in here because that's moles per liter. So we're going to go 4.56 moles of sodium hydroxide per liter, and we're going to multiply it by the liters because that'll give me the moles. Remember, that was our milliliters that we converted. And so these will cancel, and that's going to leave me with the number of moles of sodium hydroxide in 3 significant figures, 0.611 moles of sodium hydroxide. And then we have to go across the mole bridge, so I'm going to go times line, moles of sodium hydroxide to moles of phosphoric acid. Notice there's a 1 in the stoichiometric coefficient for the phosphoric acid. This one gets a 3. And so that'll cancel. And in 3 significant figures, that gives us 3 significant figures, right? Yes. Good. Good. There it is. 0.204 moles of H3PO4. Now, we want to know what its concentration is, so we're just going to divide it by the number of liters, 0.125 liters, and that in 3 significant figures will give us 1.63 moles per liter, which is the molarity of H3PO4, and that's what we were looking for. Now, if you guys, I don't think you can. Okay, so this should be your answer, and if you're off on your significant figures, take off a point, please. Number 15, you are told to make 500 mils of a 1 molar solution of sodium hydroxide. You find a solution of sodium hydroxide that's already made, but its concentration is 3.41 molar. How would you make the solution you are told to make? So this one, I am going to use M1V1 equals M2V2. And so we are making a 1.00 molar solution, and we want to make 500 mils of that. So that's the final volume. And you have, your initial molarity is 3.41 molar, and we want to know how to make it. So we need to know how much of it to use. And so we're going to divide both sides by 3.41 molar. And that will give us our initial volume. These will cancel. 3 significant figures. So our initial volume is 147, and we're left with mils. So it's going to be mils. Now, if we wanted to make 500 mils, we would use 147 mils of the original plus the difference in water. We would bring it up to 500 mils. So as long as you have the 147 mils of the original, your answer is right. And it should be in 3 significant figures because these are in 3 significant figures. Okay. I would use, each point on the way he's graded it, just figure each point is worth 3 points. So like number 14 is worth 3 points, so it's actually worth 9 points, and you can figure out the grading from there. Okay, so go ahead and use his grading, but basically everything's going to be 3 points for each of the points that he designated in his grading. All right, you guys, go ahead and have your folks sign that and bring it with you to class. If you're not happy with the grade you got on that, you just need to restudy it and do it again. You really shouldn't quit trying until you get a B, which is an 80. Or whatever you're happy with. If you want an A, then do it again and get your A. Don't study the test to redo it, though. Go back and study the chapter, the parts you're having trouble with, and do the review problems again, and then take the test again. All right, have a blessed week, and I'll go ahead and start the next chapter. And I'll see you next week.